In December of 2020, a partial collapse of the Arecibo Observatory occurred before repairs or controlled demolition could be conducted. Then finally, in 2022, the National Science Foundation announced the telescope will not be rebuilt or repaired. This ended the reign of this iconic structure, which was situated in Arecibo, Puerto Rico, and which had been a dominant reality on the island for almost 6 decades. In its heyday, the observatory's physical presence was an example of technological marvel and awe. Aside from that, its contributions to science and technology were remarkable, pioneering innovations that have contributed to the world we live in today. Construction of the telescope and its supporting facilities began in the mid-1950s under the direction of the United States Department of Defense. Arecibo, Puerto Rico was the location chosen because it was near the equator and provided researchers with a unique opportunity to study the Earth's ionosphere, which plays a crucial role in radio communication and navigation. The site was also situated in a natural limestone sinkhole, which provided a natural depression that was ideal for housing the large dish. This geographical feature made it easier to construct and support the massive radio telescope dish, which would have been challenging to build on a flat or uneven surface. The initial objective of the U.S. Department of Defense for the observatory was to conduct atmospheric and ionospheric studies for the purpose of trying to detect incoming missiles. However, by 1969, ownership of the observatory was transferred from the U.S. Department of Defense to the National Science Foundation. Under the new ownership, the Arecibo Observatory became important and influential for several reasons. The Arecibo Observatory was a leading research facility that contributed to the advancement of astronomy, including the discovery of the first binary pulsar, which led to the confirmation of Einstein's theory of general relativity. It also contributed to the study of near-Earth asteroids and helped scientists understand the structure of our galaxy. The observatory's radar capabilities also allow scientists to conduct detailed studies of planets and their moons. It provided valuable data on the surface and atmosphere of planets such as Venus and Mars. It also played a key role in atmospheric science, including studying the ionosphere and its impact on radio wave propagation. The Arecibo Observatory was not just a scientific landmark, but also a hub of technological innovation. The design and construction of the large dish, which was suspended by cables over a natural sinkhole, represented a major engineering achievement. Its innovative design set a standard for future large-scale radio telescopes and influenced the design of other large radio observatories. The observatory's radar capabilities were groundbreaking. It pioneered the use of radar to study planetary surfaces and atmospheres, contributing to our understanding of the solar system. This technology allowed for detailed observations of planets, including mapping surface features and studying atmospheric conditions. The observatory's radar technology was adapted for use in other fields, including remote sensing for Earth observation. This technology has applications in weather monitoring, environmental research, and disaster management. Also, the sheer volume of data processed by the Arecibo Observatory required advanced computing solutions. Innovations in data storage, processing, and analysis were developed to handle and interpret the vast amounts of information gathered by the observatory. The technology and techniques developed at Arecibo found applications beyond astronomy, influencing fields such as telecommunications and signal processing. Innovations initially designed for radio astronomy were often adapted for use in other areas of technology. The observatory was also a major player in the search for extraterrestrial intelligence. Its large dish was used to scan for potential signals from extraterrestrial civilizations, contributing to our understanding of the possibility of life beyond Earth. There were targeted searches to investigate specific stars or regions of space where conditions seemed favorable for the presence of extraterrestrial civilizations. By focusing on these areas, researchers hope to increase the likelihood of detecting signals from advanced civilizations. The observatory gathered data over extensive frequencies and time periods, which was crucial for filtering out false positives and identifying genuine signals of potential extraterrestrial origin. When promising signals were detected, follow-up observations were conducted to verify and analyze these signals further. The Arecibo Observatory's capabilities allowed researchers to confirm whether a detected signal was an anomaly or a legitimate extraterrestrial communication. The Arecibo Observatory also served as an important educational resource, providing tours and educational programs for schools and universities in Puerto Rico, as well as many students from across the world, to learn hands-on about radio astronomy and its applications. In addition, it was a source of pride for Puerto Ricans. The Arecibo Observatory and its dish represented an iconic image of innovation, scientific development, and education, contributing to Puerto Rico's sense of pride, identity, and reputation globally. However, like we mentioned in the beginning, the wear and tear of time and natural disasters such as earthquakes and hurricanes eventually took its toll on the aging observatory. Also, over the years, newer radio telescopes and facilities have been built in different parts of the world, including the Atacama Large Millimeter Array in Chile, which provided advanced capabilities that made the Arecibo Observatory less competitive in its abilities to carry out scientific research. And of course, the Chinese built FAST, which is now the largest radio telescope in the world, surpassing the Arecibo Observatory, which stood as the largest in the world for 53 years before the construction of FAST was completed in 2016. Overall, while the Arecibo Observatory was an important research facility and educational resource, its declining infrastructure, inadequate funding, and competition from newer technologies contributed to the decision to decommission the observatory. In 2022, the NSF announced the telescope will not be rebuilt, with an educational facility to be established on the site. Currently, it has been transformed into a STEM education center. Let us know what you think in the comment section below. Help us to spread this video by sharing. Don't forget to subscribe and turn on the notification bell for more videos.